So today we're going to be discussing relays and how they work and how to test them. So in front of me, I actually have an assortment of multimeters that I use, okay, that you guys could use. I have all sorts of shapes and sizes. This is my personal collection. I have a couple of relays, and we're going to be conducting some experiments, okay. I know you clicked on this thinking this was all about relays, but this is science class. I'm going to show you how to test them, how to wire them, and how they work. And why do we even have them? So you may be wondering, what is the function of a relay? So it's very simple. It's simply to switch on and off circuits. So in front of me, I have connected a battery. I have wired it to a switch, and at the end of the circuit I have a light. Okay, so we have positive going straight to the light, we have the negative going into the switch and going back to the battery. And since the switch is off, the light is off, but as I flip the switch, the light is on. Okay, very simple circuit. Now here we have a relay. I'm going to wire it in the same manner, and I'm going to show you how that is done. So when I'm going to wire up this relay for the circuit, I'm going to be looking at these numbers, and let me explain what they represent. You see you have an 85 and you have 86. Those are the pin numbers, okay? And this little symbol, it shows that there's a coil, okay? And then you have a 30 and an 87, and you see this symbol, it's a switch symbol, okay? So what's going to happen is, as I energize, I'm going to wire 85 and 86 together, it's going to complete the circuit and flip this switch on. So right now what I'm going to do is wire 30 and 87 together. Okay, so I look under here and I look for 30 and 87. So we're connecting circuit 30 and 87, just like we did the switch. But right now, there is no way in how to turn it on. Why? Because it turns on electrically. There's no physical switch. It's an electrical switch. So now, in order to energize this, I'm going to show you what I'm going to do. So here I have a power probe, and what you would use this for is to test circuits on your vehicle. But you could also add power, okay? Just like that, you could add power to a circuit. And what I'm going to do is, I'm going to grab the negative lead, and I'm going to put it on circuit 85. That's part of the coil, okay? And then I'm going to grab another lead and stick it in here, okay? And I'm going to energize circuit 86, okay? We have everything wired up now, okay? So now, as I introduce power into here, okay, it's gonna complete the circuit, turn the switch on, and send power into this light. And I'm gonna show you how that looks right now. See that? Okay, now the power is not coming from the power probe. The power probe is acting as the switch. So if I remove this here, okay, you can see the power probe is not connected in this circuit, because if I remove it from this terminal and just connect it straight, I could turn on the light. So these relays come in all shapes and different sizes, okay? You have this style, you have some of these, you even have some of these with 5 pins, and you also have the same as the black ones but they're gray, okay? But they all work the same. There's a coil and there's a switch, and at the end, when you introduce positive and negative to one side, the switch flips on and you're able to complete the circuit. But I'm gonna go one step further and show you how it operates in the inside. I took apart one of these relays and I'm gonna show you exactly how it works in the inside so you guys could have a better idea and how it works so you could diagnose and repair whatever vehicle or machine or device you're working on, so you could have a better understanding of what's going on so you could fix it right the first time. So just like before, I'm gonna wire up the coil, okay? So I'm gonna go one lead to the positive, one lead to the negative, and I'm gonna be using the power probe again, okay? And as I flip the switch, you could hear an audible click. But let's look inside and see what's going on, okay? So as I introduce power, you can see there's movement inside. And that is caused by the electromagnet moving the conductor. So, as you can see here on this relay that's open, there's a coil. This coil becomes the electromagnet, okay? There is a contact switch inside there that jumps from one end of the lead to the other when this electromagnet is flipped on, and it pushes down into that contact. So now I'm gonna show you, I'm gonna demonstrate how an electromagnet works so you could better understand how the relay is working. And I'm gonna be using this extension and this piece of cable, this wire, okay? I'm gonna grab it and I'm gonna wrap it around this metal core, because that is what an electromagnet is. It's a piece of wire wrapped around many times around a metal iron core, okay? So I did several loops here. The more loops I make, the stronger it will become, or the higher the voltage is or current, the stronger it will become. But for this demonstration, I think this is probably enough, okay? We'll find out here in a second. I'm gonna grab one of the leads. I'm gonna hook it up to this side, okay? That's gonna be my positive, and I'm gonna use on the power probe the negative and hook it up to the other side of the wire. So now I have completed the circuit just like you complete the coil circuit on the relay. It's the same thing. There's an electromagnet, there's a positive and negative. We're going to energize the coil and we're going to attract a piece of metal together, okay? And it's going to become an electromagnet. And I'm going to flip the switch. You can see how it works, okay? Only when I turn the power on, it becomes energized and it attracts a piece of metal. That is the same way this relay works. When I put positive and negative to one side of the coil, it attracts a piece of metal that's inside here and it completes the circuit, jumping the bridge across the switch, okay? Because it is an electro switch. And we'll do it one more time, okay? Gonna see how far back I could go with this. Oh, that was pretty far. Okay. So why am I showing you all this? Well, when you guys understand how a circuit works or any component works, you could make, fix, or design anything you want, okay? So now that we have a better understanding on how it works, I'm gonna show you how to test for it to discover if it's good or if it's a bad relay. Because you could have the relay switch on and off, but it could still be bad. And I'm gonna show you how to test for that. In front of me, I have my collection of multimeters. And if you could tell by this assortment, this collection. I am obsessed with them, okay? This is not all of them, but I just brought some of them out so you guys could see the different ones. And I wanted to demonstrate that majority of all the multimeters out there in the market right now, they do have the ohms feature where it has omega for you to test resistance, okay? So let's get started and let me show you what am I talking about. You're gonna grab a multimeter, okay? And you're gonna put it in the ohms feature, okay? And what it looks like in my multimeter, it might look a little bit different on yours, but I would like to show you that virtually every multimeter out there, let me see, here's the ohms, here's the ohms, here's the ohms. Virtually every multimeter out there has a ohms feature, okay? Some of them are going to be automatic, okay? They're going to automatically put it at the right range, okay? And some of them are going to be manual, like this one, okay? So, in order for you guys to understand what's going on when you switch a multimeter to ohms, I'm going to demonstrate how a multimeter works here, so you could understand what's going on, okay? So I have this other multimeter right next door, and I have it on voltage, okay? And I'm gonna go up to this battery to demonstrate, okay? Voltage, okay? I'm gonna get positive, negative lead. We can see in the multimeter, it shows about 12 volts, okay? 12.2, 12.21 volts, okay? This is reading voltage, okay? When you're in the ohms feature, okay, what it's doing is it's sending out a small amount of voltage through this wire, okay, collecting the amount of voltage that comes back through the other wire, okay, and then it shows you the amount of resistance. So it all depends on how much of that voltage comes back. And I'm going to demonstrate. You could do this at home if you have two multimeters. You could put one in voltage, one in ohms, and you're going to see that if you connect one lead from one multimeter, okay, to the other, you're going to see that this multimeter, since it's in ohms, has sent a current in through this multimeter, okay, through the leads, and I'm receiving it on this side, and it looks like it's about half a volt, okay, 0.60, okay, a little bit more than half a volt of electricity, okay. So in order for us to test this coil, what it's going to do is send an amount of voltage from one end to the other, and depending on how much of the voltage comes back into this multimeter, it would tell you how much of a resistance the component you're testing has. So for this demonstration now, I'm going to show you what happens when you put it in ohms, and you should always do this before you test a component for resistance. You should touch one end of the lead with the other to see what it's registering. And if you have a really sophisticated multimeter, it would let you zero out, okay, and calibrate the amount of resistance that there is in a wire. Because as the leads get older, they create more resistance, and it would give you a faulty reading, okay? But for this demonstration, I'm going to go ahead and show you. I'm going to touch this lead with this lead, okay? And we're getting zero resistance, very little. You can see there's a little bit there depending on how much I move my hands, but it's virtually zero. These are good leads, okay? These are in good shape, okay? So now when I connect one end of this relay, this coil, to the other, it's going to give me a certain value, okay? And when you're testing these relays, you could look up what the manufacturer says, okay? But if you don't have the book or the manual, okay, it should always have a high resistance value when you testing the coil. And what I mean by the coil, okay, you're going to be testing this circuit, the 85 and 86. That's the coil, okay? So I'm going to put one end on this side and one end on this side, and you're going to see we're getting about 65 ohms, okay? That is good, okay? You always want a high value. If you're seeing this, okay, and I'm going to touch them on purpose, you're seeing 0. There is something wrong with this coil, and it has shorted out in itself, okay, and it's conducting, it's touching each other, and it's no good, okay? If you're seeing something higher, that's a good sign. That's showing you that there is resistance, and that is normal on the coil side. So how would this play out in a real life scenario? Okay, so it would work out something like this. You're trying to figure out why your fan on your vehicle is not turning on. You're trying to determine whether or not it's the relay or not, okay? You warm up the vehicle, it starts up, it comes up to temperature, the fan still does not turn on. The vehicle begins, it starts to overheat, okay? Then you open up the fuse box, you locate the relay, and you can't really tell if it's turning on or off. You can't hear it turn on or off, okay? What you would do in this situation is you would locate the relay, pull it out, you would test the coil side, you would test the 85 and the 86, check the resistance, and see if the coil is good, okay? You could even energize it, just like I did with the power probe, and I'll show you how to do that once again. So you would connect the leads to the coil, and you would turn on and off the power probe and listen for an audible sound, okay? So just in case you don't have one of these power probes, okay, I'm going to show you a demonstration how you could also test the relay, okay, to check if it's turning on and off. The same way you would energize the coil, you're going to have positive and negative, and you could turn it on and off to listen to the audible sound, okay, the clicking on and off. If you test it and you hear an audible sound, it doesn't necessarily mean the relay is good, because to every relay there's two circuits, and let me explain. Just like I showed you that there's a coil side, there's a contact side that works just like the switch, okay? Just turns it on and off, and it just moves power from one end to the other, okay? You have to be able to test this as well. So I'm going to show you how I used to test these when I was in the field and I was working on all the vehicles, okay? So you would have the coil side and you have the jumper side, the switch side, okay? I would connect one lead on one side, one lead on the other side. And those leads would be connected to my multimeter, and the multimeter will be set on ohms, okay? And remember, ohms is the resistance, okay? Then I would grab my power probe and I would connect the negative side, and it really does not matter if you hook it up negative and positive or positive and negative. It really doesn't matter, okay? It's still going to get energized. I would get the negative side and the positive side, okay? And I would energize the coil, completing the circuit, creating that electromagnet, and then observing on the multimeter to see if there is continuity, if there is a contact between the switch inside the internal component of the relay. And I'm going to turn this on, and I'm going to show you that. Okay? And when you turn this on, I want you to pay attention how it says 0. Okay? This is a good working relay. Okay? And why I'm saying pay attention to the 0, because like I said before, when these leads are together, okay, it's going to show the amount of resistance. And since there's very little resistance, when I energize this relay and checked the contacts on here, I know that this relay is working properly, and I know that the contact inside here, this little piece that gets worn off, okay, I know that that's in good working order because of that. And I'm going to demonstrate it again. Okay, we're going to get the leads and hook it back up. Just in case I went too fast, I'm going to go on one side. This is just like the switch, like I was showing you. And then I'm going to go on the other side. There is nothing on the multimeter yet, not until I energize the circuit. Okay, now we could see we're down to 0, 0.2. That's still acceptable. You know, it's traveling through this wire. But if this number, this value, was to go up to, let's say, 5, you had to 1, 1.6, 7, 8, a high value number right here before this decimal, you should double check that relay, okay? Because more than likely it is worn and it's no longer working. And a lot of the times, really good technicians will overlook this part, okay? And I would come behind them, I would discover this, and I would be crowned the hero, but I really was not the hero. I just took the time to test the components, okay? And a lot of the times, okay, it's as simple as just taking your time and measuring all the values all the way around. Because, okay, just like I demonstrated, if you could hear the audible clicking, it does not mean this relay is good, okay? There's another part of the circuit here that you have to test. You have to test both parts in order to determine if it's good or bad. So the question is, why do we even have relays to begin with? So let me show you. Down here on my table, I have created a simple circuit, okay? And this is something similar this is a circuit that's similar that you will find in your vehicle right now, okay? We have a relay, we have a trigger, okay? Majority of the time, this trigger is going to be created by the PCM or ECU, the computer system of your vehicle, okay? You have one end is positive, one end is negative. Majority of the time, the computer, it's sending a negative signal to complete the circuit to turn this relay into an electromagnet, okay? I have it hooked up to the power probe, so we're going to simulate a computer system. We're going to simulate that this is the computer system. And it says, hey, the vehicle's coolant temperature is really hot. Let's turn on the fan. Okay, the fan is on, okay? But nothing turned on. That's because I haven't connected the wires to the other end like I was showing you before. So I'm going to come right here. I'm going to connect one of these ends to the relay. Okay. That's connected there. And then I'm going to connect the other end of this wire to this relay end right here. Okay. So right now this is what I have going on. I have the positive lead coming into the relay, the negative lead going straight into the motor, and the last lead that connects to the relay right here okay, it's for the fan. So when I energize this coil, it's going to complete the circuit here. It's going to flip the switch, turning on the fan. So once again, the vehicle registers a hot coolant temperature. It says, let's turn on the fan. And the fan is energized. So this computer system can trigger that relay with very little current. That is why we have relays. Relays do the hard lifting, and the computer systems just trigger on and off the switches. Alright guys, so I hope this video was helpful. I hope you guys learned a lot. If you did, give me a thumbs up. If you find this useful, share it with somebody, share it with a technician that's out there that might be struggling and trying to figure out how does the electrical system work or a relay work on a vehicle. I'm going to be doing a series of videos just like this. Okay. At the end of all of this, I would like to say I am a certified master tech. Okay. I worked in the field many years, and right now I am just dedicating myself to giving back to YouTube, because I have to say, a lot of the times when I was first starting out, YouTube was the place that I went to figure out how to do things. So thank you so much for watching, and subscribe.